All right, little curveball to start. Trying to find the inverse sine of root 2 over 2. You know, if we're really comfortable with the unit circle here, this wouldn't be too bad to find. If you're comfortable with the unit circle, you'd be saying to yourself, well, let's see, by definition, sine always went with, was it x or y? Which one was it? Remember? Sine always went with y, right? So you could say to yourself, where are the y values? Root 2 over 2 on the unit circle. That's one way to do this. But if we're consistent with the right triangle approach we've been talking about here recently, let me give you a real quick tip on any root 2 over 2 stuff that you come across. Root 2 over 2 came from 1 over root 2. Remember, we usually leave our answers like that, but if you rationalize it, you multiply the top and the bottom by root 2, what do you get? You get root 2 over 2 back. So anytime you see root 2 over 2, you may want to rewrite the problem and say, okay, we're finding the inverse sine of 1 over root 2. So if we're finding the inverse sine, and what we're plugging into that is 1 over root 2. Using a right triangle approach, sine goes with opposite over hypotenuse. So opposite side would be 1, hypotenuse would be root 2. You consider your right triangles where that's even possible. The opposite side is 1, the hypotenuse is root 2. What triangle comes to mind? Okay, the 45 right triangle. So if it's a 45 right triangle, we know what our degree measure is, 45 degrees, but we want everything in terms of radians on this interval from 0 to 2 pi. Instead of writing 45 degrees, I write pi over 4. The inverse sine of root 2 over 2, also known as the inverse sine of 1 over root 2, is simply pi over 4. And as functions go, if we're real specific with inverses, that's your only answer. But for where we're going next, when we're trying to solve equations, we would like to find some other possibilities on this interval from 0 to 2 pi. So now we address, once again, since we're talking about sine, where else is sine going to be positive? Because these values we're plugging in here are positive. It's positive in the first. We've got that answer. Pi over 4 is in the first. It's positive in the second. Well, now I need the pi over 4 answer that's in the second quadrant. If you got your unit circle, you know it's 3 pi over 4. If you don't have your unit circle and you've memorized the unit circle, then you also know it's 3 pi over 4. But if you don't have any of that, you better start counting. Remember our little counting trick? Where you count 1/4, that's the first quadrant here, but then 2/4 takes you halfway, so you're up here. So 2/4, we don't count that because that's pi over 2. 3/4 takes us over here. Oh, okay, that works. 3 pi over 4. So there are only two answers that could work here. Let's try cosine one. Let's take the inverse cosine of, well, let's stick with this root 2 over 2 theme, only this time make it negative. All right, this time, making it negative does make a difference, but let's start by rewriting the whole root 2 over 2 bit again and making this negative 1 over root 2. Working in terms of cosine. Cosine means adjacent over hypotenuse, right? So we're talking adjacent measure here, hypotenuse measure there. Where would that even be possible? Which of the two right triangles? Okay, it's still 45, right? So we're thinking pi over 4 might be a good place to start. But This is negative. Since that's negative, and we're looking at this in terms of cosine, cosine is only positive in the first and the fourth quadrants, so second and third quadrant is what we want to pay attention to. That means you want the pi over 4 stuff from those two quadrants. So in the second quadrant, I already did this on the previous example, the pi over 4 stuff would be 3 pi over 4, right? Whoops. It's supposed to be a 3 pi over 4 there. Kind of got away from me. If we continue our little count, 3 pi over 4 we know is over here in the second. 4 pi over 4 would take us over to this axis, right? 5 pi over 4 would take us down here to the third. So there's what we need from the third quadrant. There are the only two possible answers that would work here for this inverse. All right, for this inverse tangent one, let me give you a ratio of root 3 over 3 that we're plugging in. And like I explained with the whole root 2 over 2 bit being equal to 1 over root 2, as you consider root 3 over 3, well, 1 over root 3 is equivalent to root 3 over 3. Right? Rationalize the denominator, multiply root 3 to top to bottom, you get root 3 over 3 back. So if I rewrite this one, I've got the inverse tangent of 1 over root 3. Talking in terms of tangent, thinking of SOHCAHTOA, we're looking at opposite over adjacent here. We look at our two right triangles. We look to see where we might have an opposite side of 1 and an adjacent side of root 3. What triangle comes to mind? 30-60. So if it's a 30-60, opposite, if it's going to be 1, we need to align ourselves with 30 degrees, right? 30 degrees as a radian measure is what? Pi over 6. So pi over 6 builds the foundation for our answer down here. Now this is positive, right? So if we look at all students taking calculus, first quadrant would be positive for tangent, so we got one answer. Third quadrant also would be positive. So we need the pi over 6 value that goes in the third quadrant. Any guesses? What is it? 7 pi over 6. Good. Those are the only two that would work based on the directions we have. All right, another spin on these types of problems. We've got a few where we stick to playing with triangles, but this time it's not the two special ones that we're always dealing with. For this set of directions, let's evaluate the expression by sketching a triangle. And what we're going to do here is we're going to combine a few functions together. We're going to have problems presented where maybe we have a cosine, and plugged into that cosine is an inverse. So here an inverse sine, we'll say. And plugged into that inverse, we'll have some ratio like 8/17. So whenever we combine functions, we start with the innermost stuff here, and we work our way out. Now with this innermost stuff, since we're supposed to be able to relate to a right triangle somehow, let's sketch out our right triangle. Give ourselves some sort of angle to work with, theta, x, whatever. Based on the previous problems we've done, when we look at this inverse stuff, this inverse is supposed to have a connection to SOHCAHTOA somehow, and with sine we know we've got opposite over hypotenuse, right? So if I want to relate to my angle x down here, I could say that the opposite side is 8, the hypotenuse is 17. If you're good with your Pythagorean triples, you know what the other side is. It's 15, good. And if we're not so good with those triples, we just use the Pythagorean theorem. But here's what's really nice. See this inside stuff? That gives us the setup for the triangle, which helps us find all the sides. Once we have all that information, work to the outside and look at cosine. Cosine is adjacent over hypotenuse, right? So what's adjacent to x? 15. And the hypotenuse is still 17, so my answer is 15 over 17. That's it. All right, so if we try one of these that's got a reciprocal in here, also try one where maybe it's not a Pythagorean triple that you're dealing with on the triangle. We'll start on the inside again. On the inside, since we have an inverse we're dealing with, that helps us to set up our right triangle. Once again, we give ourselves an angle to work with. We'll call it x. For inverse tangent of 4, this is the same thing as saying 4 over 1, right? Tangent, using the SOHCAHTOA approach, is going to be opposite over adjacent. So comparing to x down here, opposite would have to be 4, adjacent 1, not a Pythagorean triple, so to figure out my hypotenuse, gotta do the 1 squared plus the 4 squared equals the h squared.
Thanks, Emma.
Solving for h, well, let's see, this would be 1 plus 16, so that's 17. You got 17 equals h squared. So h is going to be the square root of 17. So all the inside stuff taken care of, gave us the triangle, even found this extra side to work with. Now we go out to the cosecant. We know cosecant's reciprocal is sine. So let's think for a moment how we find sine. Sine is opposite over hypotenuse. So sine would be 4 over root 17, right? But we want cosecant, so we flip that. It's root 17 over 4.